Hey everyone, welcome back to this new chapter. This chapter is also one of the fundamental chapters where we'll be picking a small topic which is payment processor. We'll code it, we'll see what all are the flaws, then we'll learn what strategy design pattern is, and then we'll implement payment processor using the strategy design pattern. So going forward, wherever the payment processor would be used, you can refer to this and integrate payment processor in any of the application. One such application is e-commerce, parking lot, or any other application which you can think of. Moreover, we'll go into the depth of strategy design pattern. Why do we need it? What is strategy design pattern? And we'll also learn what all other applications can be there which can be built using strategy design pattern. Without wasting time, let's move on to the chapter. Let's design payment processor. We'll keep it simple. We'll not go much into the depth of it. Let's start. What a payment processor does. So whenever you go into e-commerce platform, you have put something in your cart, then you press pay. There you get options, different options. Pay by credit card, PayPal payment, UPI payment, Stripe payment, cash payment. So all of it, these are different types of payment. So there would be payment processor. Payment processor's role is to handle all these kinds of payments. Let's start with the use case diagram like we generally do. Payment processor, it would process credit card payments. Next is it would process Stripe payment also. It would process PayPal payment also. It would process UPI payments also. So there would be different, but let's go ahead with these three. Design would be similar for others also. Okay. Since now we are done with the use case diagram, let's move on to the class diagram then. Payment processor. So like we first saw, its first responsibility is to process credit card payments. We can keep the return type as void and let's keep it as public. What will it take as an argument? It will take card number, CVV, expiry date, and of course amount. How much amount do we need to pay? Let's put string card number, string expiry date, string CVV. Of course amount should be, let's keep it in double. So other, if we see it here, okay, Stripe and PayPal. So let's make other two functions, void process Stripe payment. And generally in Stripe it takes an API key, right? So API key, and of course we would take an amount. And let's go for other is process PayPal payment. While processing PayPal payment, I think it takes an argument as email, password, and amount, right? So string email, string password, and double amount. This should be the class diagram, I feel, for payment processor. If there are more functions which you want to add to it, you can add. I think we are pretty much done with the class diagram. Small piece of code. Let's go ahead and implement it. Let's build a small class here, payment processor. Let's just quickly implement all these three functions which it had. Do you think payment processor would have any data members? It might have data members according to processing of PayPal or credit card, but of course we need not to go into the depth of it. We just have to handle the strategies here. We just have to handle the ways here. We'll see how we would design that a call would come to. Basically, when you select credit card or PayPal, it would come to these methods. And of course, interior working, we are not going into the depth of it. So public void process credit card payment. What will it take? It will take string card number, string CVV, string, oh, I wrote CSS, CVV, string expiry date, and yeah, it would take the amount. So here we can have the processing, let's say processing, whatever API calls you need to make to the gateway or bank's APIs. And we can here have us just a simple, let's say, print that if our call is coming here. So system dot println in credit card payment. Same ways, let's quickly implement the other two functions also. Let's just quickly write the main function also from where we can access all these functions. So we'll take a instance of payment processor. Now we can call these different methods right here. So payment processor dot process credit card payment. It would take a card number. So let's say it took this card number. Okay. Then this would take CVV. So let's say the CVV is 322. Third one is expiry date. And similarly, we can call methods, other methods also. So payment processor dot process PayPal payment. First one is email. So let's say let's write any email. Okay. Same ways, if we want to call Stripe payments, so let's just quickly call that also. Let's say this is the API key and this is the amount. Okay, great. So of course this will run, right? And yeah, in credit card payment, in PayPal payment, and in Stripe payment. Great. This is working. What are the flaws that you can see in it? So if you see right here, do you see a lot of code duplication? Every process method is present inside the payment processor. Do you see code duplication here? So first is that this system.out.println line. Do you see it has been duplicated everywhere? There's just one simple line. Of course, there would be API calls that would be made while processing, if you see. So processing would be, they would be making some API calls maybe to the gateway or to the bank. So that code would be duplicated, right? So there's a lot of duplication here that's happening. And we can optimize this. So now let's say tomorrow going forward, a new payment method came in, which is UPI, which means you'll have to change payment processor if you want to have a payment via UPI, which means this will violate open close principle, which is another flaw that we can see in this piece of code. Do you see any other flaws? There's one more flaw. If you see every program, we have to write test cases to test it. So it would be difficult for us to write test cases for this. Why? Because each and every payment method is tightly coupled to this payment processor actually, which makes it difficult for us to substitute and mock things. So that's why it would be difficult in testing also. So now we have seen what all are the flaws with the previous class diagram which we built, or the previous piece of code which we wrote. Let's try and optimize that piece of code. And later on, we'll see what strategy pattern actually is. So now if you see this class diagram, we saw that process credit card, process Stripe payment, process PayPal payment, all of these methods are basically tightly coupled. This was one of the issues. So let's decouple them. First of all, you can have PayPal payment, Stripe payment, and the third one is credit payment. And all of these are payment strategies, if you see, or basically payment options, which you can say, right? So all of them was having a similar function, but they wanted to implement it in their own ways. There were many common things also. So what we can do is we can make an interface payment strategy. So we made this interface payment strategy, and if you see PayPal payment, it is also a payment strategy. Stripe, it is also a payment strategy. Credit card, it is also a payment strategy. So let's go and implement it. So so there is a relationship. You heard my words right. PayPal payment is a payment strategy. Right. Stripe payment is a payment strategy. Since we are implementing it also, so this makes complete sense. Okay. Same ways for credit card payment also. Since all of them would have a function of processing the payment, what we can do is we can make a function process payment. Provided PayPal payment would take different arguments, Stripe payment would take different arguments, credit card payment would take different arguments. So that's why we are keeping process payment. And for credit card payment, we can have card number as the data member, expiry as the another data member, expiry date basically of the card. And third one could be CVV. Same goes for Stripe. Stripe we can have API key. So the only thing would be API key, right? For Stripe. For PayPal, it could be ID and password. So if anybody would make a PayPal payment, of course, they'll have to feed in with ID and password, and here the API key for Stripe. And for credit card, card number, expiry, and CVV, right? I guess these would be the data members for all of them. What do you think process payment would take? In process payment, what payment, how much payment do we have to process? Amount, right? So we can pass amount as an argument in process payment, and of course, all three would have to implement it. They can implement it in their own ways, however they want. So now if you see, we have decoupled the payments, right? So going forward, if I want to make some changes in PayPal payment, only my PayPal payment would be changed. It would not harm Stripe or credit card payment. It will not. Let's move ahead. Now we have payment strategy. So what will be passed in the payment processor? So if we see in payment processor, we'll have a payment strategy, right? On which strategy or which kind of payment do you want to make, right? So if a user in an e-commerce platform, suppose you have put everything in your cart and you selected card, right? So you'll feed in card number, CVV and whatsoever, and your payment processor will go ahead with the card payment strategy, right? Payment processor would always have a strategy. So we can have a payment strategy. Payment processor would always process the payment, right? So if I talk about the class function, so it will have process payment. And what will be the amount? So amount would be passed in the arguments, right? So in process payment, what payment processor can do? Payment processor can basically call payment strategy to process its payment. So in process payment, what we can do is payment strategy dot process payment, right? So this will call this one. And since everyone has implemented it in their own ways, so that payment strategy process payment would be called. If you see this class diagram now, this is decoupled. Going forward, let's say there is one more type of strategy that comes in. Let's say debit card. What all changes will you have to make? Just think about this or look at this class diagram. What will you do? Debit card strategy would also implement the process payment method. So there would be one more class debit and it would take its parameters. I think same parameters would be there and it would process payment in its own way, right? So this process payment function would be implemented by debit card also, right? So everything is loosely coupled. Great. Is there duplication? I can see there is no duplication. Whatever common would be there can be put into the common this payment strategy, right? Whatever common would be there. Okay. Testing of this would be really easier because you can mock objects now very easily. Okay. Now, payment processor is also following open close principle. If you see, this is open for extension. You can extend this and it is closed for modification. There would be no modification, right? Last, if you see, we are also following single responsibility principle now. For each and every strategy, we have a different class altogether. So this is what is called strategy design pattern. So since payment processor has a payment strategy, okay, so there would be has a relation between payment processor and payment strategy. Now, if you see, this is what is actually called strategy design pattern. Now, what is strategy design pattern? Okay, so hear my words properly. We'll break that line. This is the definition of actually strategy design pattern. Strategy design pattern is a behavioral pattern that allows you to define family of algorithms, encapsulate each one as an object, make them interchangeable at the runtime. This pattern also allows client to use different algorithms without having to know the details of the implementation. Okay, I know it's a big definition. Let's break it down into the points. So first of all, it's a behavioral design pattern. You can see we are changing the behavior. That's why it is behavioral design pattern. In this, we define a family of algorithms. So have we defined a family of algorithms? Yes, we have defined family of algorithms. Encapsulate each one into an object. Yes, we have encapsulated each payment strategy or each algo into a object. Make them interchangeable at runtime. Can we interchange them at runtime? Yes, of course we can. If we have a setter function in payment processor, we can change it at the runtime. Allows client to use different algos without knowing the details of how it's implemented. Since it's encapsulated, user don't want to see how the payment strategy is implemented. User don't want to. They just select credit card payment. They just fill in the details and they're done. The payment happens, right? In this also, process payment function would be implemented by this credit card pay strategy, right? How would the user get to know how is it implemented? We allow client to use different algos, right? Without them knowing what the details are. Strategy design pattern is pretty much clear. It would get more clear when we code this. So please stay here and let's code it. If you see, this is the old payment processor. Let's make a new one using the class diagram which we have built now. Before that, let's build the strategies first. So let's build first strategy. So payment strategy would only have process payment. Okay, public void process payment and it will take an amount. So let's keep it double. Let it implement payment strategy. Okay, let's implement the functions. Okay, so let's system.out.println in credit card payment. Now let's make PayPal payment strategy also. Okay. Implement payment strategy. Let's just copy this to keep it really fast and simple in. And let's make Stripe also. We are pretty much done with the payment strategies. Let's just quickly make payment processor Stripe using strategy pattern. So let's make a new file, payment processor. So let's name it payment processor using strategy pattern. Okay. Now, so it will always have a payment strategy. So private payment strategy, let's payment strategy. So since payment processor can't operate without a payment strategy, so let's have it in the constructor itself while the person makes a payment processor. So public payment processor using payment strategy. Okay, so this dot payment strategy equals payment strategy. Okay, so now let's write the second member function, which is the process payment, right? So public void process payment double amount. So what we'll do is we'll call the process payment of the payment strategy. So payment strategy dot process payment amount, and we are pretty much done. Let's see it in action. Actually, let's go in the main function and let's see it in action. Okay, so now payment processor using, okay, so we took one instance. Okay, so now we have to feed in the strategy in the constructor when we declare the payment processor, right? So let's say right now I want to have a, let's say, credit card payment. Okay, so let's have credit card payment strategy equal to new credit card payment strategy. So in credit card payment strategy, we actually forgot to take the arguments. So let's just quickly write the arguments also. Okay. Okay. So this is one. In PayPal strategy, we'll get ID and password. So private string, let's copy it from previous payment processor, email and password. Okay, so it was having email and password. Okay. Let's generate the constructor. Okay, great. Let's go for Stripe payment also. Stripe was taking an API key, that is it. So private string API key. Let's just quickly declare the constructor. So here we have. Now let's just quickly pass the same things actually. In the payment strategy, since we have to feed in the strategy, so we have the strategy here and we feed in credit card payment strategy. So now you see we have fed, or the strategy is being chosen at the runtime here, and things can happen. Let's just print it. Okay, we didn't call the process payment actually. So let's call the process payment dot process payment, let's say. Okay, and let's now run it. Okay, so you can see we are in credit card payment, right? We can do one more thing. Now if you see, we can feed in the other strategy also, right? We can interchange the strategy. So for interchanging the strategy, if we make a setter function here, right? We forgot to make the setter function. So let's make a setter function also, which we can generate. We do not want the getter function actually. We have a setter function. So now if you want to change the strategy, just feed in the strategy, just set the strategy and you'll be good to go. So PayPal strategy, PayPal equal to new, and we have to pass in the email. So let's say this is the email and this is the password. Okay. And now since we can use the same payment processor, we need not to make another new processor. Why to waste memory, right? Dot set payment strategy, and now we can again call process payment. So let's see, and now let's run it again. We have it printed at the end. Now a user came in with a new payment strategy. What all changes will you have to make? Will you have to make change in this payment processor? No. What will you do? You'll make one new strategy. Let's name it new strategy for now. This could be any. So new strategy. Okay, let it implement the new payment strategy. Did you change the payment processor? No. you're able to add one more strategy which will be easier to test also, because it's a separate object altogether. You have encapsulated also, and you can feed in that payment strategy during the runtime. User can basically choose during the runtime only. So this is far better than the previous design which we saw. So this is all for strategy design pattern. I hope you would have understood what strategy design pattern is. So how we are able to deal with payment processor in a very good way. Wherever payment processor would be used, e-commerce, parking lot, wherever, this is the way to go. If you see, there are few more things. First of all, we have encapsulated the algorithms. Second is, we have flexibility and extensibility. Flexibility and extensibility, how? Because it allows us to choose different algorithms at the runtime. That is why it made easier to add new algorithms, okay, without modifying the existing code. We didn't modify any existing code. That is why it is easier. Third is, we have separation of concerns right here. So anything, if you want to change in PayPal payment strategy, you can do it. It's separate. Single responsibility principle has been followed. Now, fourth one is, it is really simple to see. We have all the strategies at one place. We have payment processor wherein you feed in the payment strategy and it would be done. So code is much more readable now and manageable also. So these are the benefits of strategy design pattern. You must be wondering which all places can we use other than payment. So if you know, there are, when you compress a file in the laptop, so there are many compression algorithms, right? So one is gzip, Brotli is also there, zlib is also there, bzip 2 is also there. So these are different compression algorithms. If question is, let's say that user decides the compression algorithm and you have to compress it in that way, this is the way to go. Use strategy design pattern. Encryption algorithms, routing algorithms. If a user chooses which routing algorithm does it want to choose, this is the way to go. Last one, which I am pretty sure you would have seen, sorting algorithms also. So if somebody wants to sort using quick sort or merge sort, basically this is the way to go. Use strategy design pattern. Again, everything has been followed here. I hope everything would be clear to you right here. If you have any doubts, please ask in the discussions panel below. We would be trying to answer your queries ASAP. Thank you so much for seeing this video till the end.